Okay, students. So now let us solve the problems on linear differential equation. Clear? So in the previous class, we have seen how to solve the linear differential equations, the theoretical format. That means algorithm of linear differential equation has been already studied in the previous class. So now let us move for the problems on linear differential equation. Clear? Okay. So here the solution of the differential equation dy by dx plus y equal to cos x is they are asking. That means the solution of dy by dx plus y equal to cos x. Are you getting my point? They are asking the solution of dy by dx plus y equal to cos x. Okay. So you remember the technique of solving the linear differential equation where P and Q has to be identified. Clear? Here dy by dx plus py equal to Q. This is the form of linear differential equation. So here P is equal to what? P is equal to 1. Q is equal to cos x. Are you getting my point? This is my first problem. So I am solving in detail. Clear? So P equal to 1, Q equal to cos x. So after finding P and Q, you must calculate integrating factor. That is IF. What is IF equal to? IF equal to integration of e to the power of P with respect to dx. But what is P here? P is 1, so I will take here 1, so integration of e to the power of 1 with respect to dx. So it will be what? It will be, this is not like this. Integrating factor is equal to e to the power of integration of p with respect to dx. Clear? So p value is what? 1. So integration of 1 with respect to dx will be what? E raised to x. Are you clear? So IF you have got e to the power of x. Now you have to simplify the equation y into e power x equal to integration of e power x into cos x with respect to dx plus c. This thing you have to simplify. Clear? Okay. So here u into v form you have to know what is Euclid method. Clear? Euclid method means inverse, logarithm, algebraic, trigonometrical and exponential. Clear? So first trigonometric comes, next exponential comes. Clear? So here the first function will be cos x, the second function will be e power x. Are you getting my point? So y into e power x equal to integration of e power x into cos x dx plus c. No problem. Okay. Now we have to integrate this. Clear? So let us solve that. Integration of e power x into cos x with respect to dx. I will take it as I. Clear? So this will be equal to cos x, integration of e power x is e power x minus integration of, next integration of e power x is, you know that it is e power x, differentiation of cos x is minus sin x. So this will be plus with respect to dx. Are you getting my point? Clear, students? That means I am applying u into v form. Clear? The product rule of integration. Okay. So now this is equal to e power x into cos x. Again this has to be integrated. First term is sin x. No problem. Integration of e power x is e power x minus integration of, now write e power x as it is, differentiation of sin x is what? That is cos x with respect to dx. Clear? So now see here, we have taken this term as I. Again we are approaching to I. Clear? We have started with I. Again we are approaching to I. That means this term can be replaced by I. That will be minus I. You take minus I on this side. It will be equal to 2I it is equal to e power x into cos x plus sin x. E power x into cos x plus sin x. Are you getting my point? You can write plus c, that is integral constant, no problem. So now 2, if you take on this side, it will be e power x divided by 2 into cos x plus sin x. So in the place of e power x into cos x, what you can write? Y into e power x equal to e power x divided by 2 multiplied with cos x plus sin x plus c. So both sides you have e power x, that is common. If you take e power x common and if you simplify it, e power x will be get cancelled. It will be 1. Here you will get e power of minus x. That means I am taking e power x common from both the sides and I am getting cancelled on both the sides. So y equal to 1 by 2 cos x plus sin x plus c e power minus x you are going to have. So this will be your answer. So you see in your solution, what is your answer? Y equal to, so y equal to 1 by 2 cos x plus sin x plus c e power of minus x. So option A will be your answer. Clear, students? So here if you know the formulas, it will be very easy. Are you getting my point? If you know the formulas, it will be very easy. See, it can be solved in 2 to 3 lines also. How? Directly you write if. You know, by seeing this p is 1. By seeing this, you know p is 1. If is 1. If if is 1, you know the formula of integrating factor, e to the power of integration of 1 dx. So it will be e power x. So if is e power x means y into e power x equal to integration of e power x into cos x dx plus c. This has to be simplified. Clear? So here you must know one formula. What is that formula? Formula is integration of e raised to x into cos bx is equal to e raised to ax divided by a square plus b square a cos bx plus a sin bx. This formula you must know. Clear? If you know that formula, then it will be very easy. Are you getting my point? So if you use this formula here, it will be what? Y into e power x by 2 sin cos x plus sin x. It will be cos x plus sin x plus c. So further you can take e power x common and you can simplify. That means you must know the formulas. Clear? If you don't want to solve this much all things, if you know the formula, it can be very easy. Are you getting my point? By using the formulas, we can solve it only in 3 steps also. That will be a very shortcut. Clear? If you don't know the formula, you have to go step by step where you have solved this thing. Clear? Solving step by step will be very lengthy in your exams. That's why you be perfect as much as possible with your definitions and formulas, so that the problem will be very easy. Clear, students? Let us go for the next problem. Okay, students, now let us go for the second problem of solving linear differential equations. Clear? Okay, so see here, p value is, first you have to know the linear differential equation of dy by dx plus py equal to q. P and q may be the notations of r and s also, no problem. Clear? So dy by dx plus py equal to q. What is p here? P equal to cot x. And what is q? Q is equal to 2 cos x. No problem. Clear? So next what we have to find? We have to find integrating factor if. Clear? What is if formula? If equal to e to the power of integration of cot x with respect to dx. So it will be equal to e to the power of log of sin x. It will be e power of log of sin x. Clear? So now see here, log and e are inverse functions to each other. Are you getting my point? Log and e are inverse functions to each other. So as you all know, f inverse of f of x will be x. So for that reason, these two are inverse functions to each other. So we will get sin x as our output for integrating factor. Are you clear? So you must be very careful while solving. If e to the power of log of any function, please keep in mind e power of log of f of x will be always equal to f of x. Are you getting my point? E to the power of log of f of x will always give you output as f of x. Clear? Okay. So now if is sin x. Integrating factor is sin x. Clear? We have to solve y into sin x equal to integration of q is what? Q is 2 cos x into sin x with respect to dx plus c. We have to integrate this. Clear? So by integrating y sin x equal to, see here you have 2 cos x into sin x. Are you getting my point? You have integration of 2 cos x into sin x. 2 cos x into sin x can be written as what? It can be written as sin 2x with respect to dx plus c. Clear? So again, sin integral is minus cos. You are going to have y sin x minus cos 2x divided by 2 plus c. I think you got my solution. Clear? So now see what you have in your options. You have 2y sin x, 2y sin x. Clear? So that means this 2 has to be multiplied here. What you are going to have? 2y sin x. If I take minus on this side, it will be plus cos of 2x equal to, by LCM it will be 2c. Clear? Okay. 2y, here you have y, then it is not your answer. Here you have 2y, so let us check 2y sin x plus cos x. That means you must have 2 here. See, cos 2x. So this is also not your answer. Y sin x you have. This is also not your answer. 2y sin x plus cos 2x. So this is your constant. Again it can be written as c. No problem, because multiplying constant by 2, again you will get a constant. So that's why it can also be written as c. No problem. So that's why option D is your answer for the solution of the differential equation dy by dx plus y cot x equal to 2 cos x. I think you got the solution of the differential equation, problem number 2. Clear? Okay. Okay students, now let us go for the third problem, that is integrating factor of equation x square plus 1 into dy by dx plus 2xy equal to x square minus 1. Clear? Okay. So this is the given differential equation and they are asking integrating factor, that means if. They are asking only integrating factor, that is if. No problem, let us solve if also and let us solve the solution also. So it will be the practice. Clear? Okay. So now dy by dx plus, this equation can be written as 2xy divided by x square plus 1 equal to x square minus 1 divided by x square plus 1. Clear? So here p equal to 2x divided by x square plus 1, q equal to x square minus 1 divided by x square plus 1. Clear? So using p you have to find integrating factor. So that will be if equal to e to the power of integration of 2x divided by x square plus 1 with respect to dx. Clear? Okay. This function is in the form of integration of f dash of x divided by f of x. That means you must remember the formula of integration of f dash of x divided by f of x. If I differentiate x square plus 1, you are going to get 2x. So that's why it is in the form of f dash of x divided by f of x. So here you are going to have e to the power of log of x square plus 1. Clear? Again you must have f inverse of f of x formula. What is f inverse of f of x formula? X. Clear? So here e and log are inverse functions to each other. Therefore it will be equal to x square plus 1. That means integrating factor is x square plus 1. Okay. Option A will be the answer for integrating factor. So now let us not leave it here. For our practice, let us solve the solution also. For solving the solution, y into x square plus 1 you have to multiply. This will be equal to integration of what? Q, x square minus 1 divided by x square plus 1 multiplied with if, that is x square plus 1 with respect to dx plus c. This you have to simplify. Clear? So we can cancel x square plus 1 and x square plus 1. You will remain with x square minus 1. If you integrate that, y into x square plus 1, it will be equal to x cube by 3 minus x plus c. So this is the solution of this differential equation. No problem, they have not asked the solution, they have just asked what is integrating factor. So integrating factor will be x square plus 1. Option A is the correct answer. So this will be the solution for the given differential equation. Clear, students? So I think you got an idea of solving the linear differential equation. Now let us solve some problems on another method of the type dx by dy plus px equal to q. Till now we have solved dy by dx plus py equal to q. Clear? So now let us solve second type. Clear? So till now we have solved dy by dx plus py equal to q. Now let us solve some of the problems on dx by dy plus px equal to q, and let us see how to simplify the second type problems. Okay students, now let us solve the fourth problem on linear differential equations. Clear? Okay. So what is your differential equation here? Dy by dx equal to 1 by x plus y square. Dy by dx equal to 1 by x plus y square. If you see this, you can't solve it with the form of dy by dx plus py equal to q. You can't bring to this form that particular differential equation. Clear? So for that reason, if you see this differential equation, you can write it as dx by dy equal to x plus y square. Are you clear? So now you can bring it to the form dx by dy plus px equal to q. For the second form, you can bring your differential equation. Clear? So that will be dx by dy minus x equal to y square. Are you clear? So now p equal to what? P equal to minus 1, q equal to what? Y square. Clear? So now you have to simplify integrating factor and then you have to solve your differential equation. So let us solve integrating factor. That is if will be equal to e to the power of integration of minus 1 with respect to dy, that is equal to e raised to minus y. Clear? So integrating factor will be e to the power of minus y. Okay. So now using this if term, you have to simplify your differential equation, that is x into e raised to minus y, because it is x, sorry, why it will be x, because dx by dy plus px equal to q is form of your differential equation. In this form you have to multiply x, in the first form you have to multiply y. Okay, so in the next second form you have to multiply the x into e to the power of minus y, that will be equal to what? See, integration of q term is y square, so that is e raised to minus y into y square with respect to dx plus c. This equation you have to solve now. Clear? Okay. Again this is in the form of islet. In the islet, exponential form will be the last one. So for that's why y square is first, e to the power of minus y is second. Clear? So you can you can use islet form and you can simplify. Clear? Okay. X into e to the power of minus y equal to, what is your first term? Y square. Second term has to be integrated, so it will be e raised to minus y divided by minus 1. Here it will be minus integration of the term which you have integrated here, you have to write here. Clear? So that will be minus into minus plus e raised to minus y. Differentiation of your first term will be 2y with respect to dy plus c. Okay. Now we have to simplify that again. See here, x into e raised to minus y minus y square into e raised to minus y. This 2 is as it is, no problem. Again you have to use islet form here, so it will be y e raised to minus y divided by minus 1. Minus into minus will be plus, e raised to minus y, differentiation of y will be 1 dx plus c. So this will be your equation. Okay. So now you got these terms, you write simplification of this. X into e to the power of minus y square into e raised to minus y. This will be minus 2y into e to the power of minus y. Again it will be minus, okay, here it is plus, okay, plus integration of e to the power of minus y will be minus e to the power of minus y plus c. No problem. Which term is common? E raised to minus y is common. You take e raised to minus y common term and simplify it. So it will be x equal to minus y square minus 2y minus 1 plus c into e raised to y. So this will be your solution for the given differential equation. That means you must be perfect in solving the islet form. Are you clear? If you are perfect in solving the islet form, then the solution will be very easy. Okay. So for that reason, now what is your answer? X equal to minus y square minus 2y minus 2. But here we got minus 1. Here we got minus 1. Where is this from minus 1? See here. Okay. 2 is multiplied to this. So that's why it will be 2 into e to the power of minus y. So it will be minus 2. Okay. So answer is minus y square minus 2y minus 2 plus c into e to the power of y. Anyways, there is no 1. There is no 1. It should be minus 2. So minus 2 already we have simplified from this. Just one small mistake, no problem. So that we have already calculated, that will be minus 2. So option D will be your correct answer. Don't do the mistakes as I done. Clear? So small mistakes will be making your wrong decision, your solutions. So please don't make mistakes as I do. Clear? So that you have to be perfect. Okay, now let us go for the fifth problem. Clear? The solution of the equation x plus 2y cube dy by dx minus y equal to 0. Okay, so this can be written as dy by dx equal to y divided by x plus 2y cube. But again, you can't solve it by the form. You can't solve it by the form dy by dx plus py equal to q. So for that reason, you have to go for the second form, that is dx by dy plus px equal to q. You have to go for the second form and you have to simplify. So let us take it as dx by dy equal to x plus 2y cube divided by y. Dx by dy equal to x plus 2y cube divided by y. Okay. Now let us simplify the terms from LHS and RHS. So it will be dx by dy minus x by y equal to 2y square. If I simplify it, it will be dx by dy minus x by y equal to 2y square. So now p equal to minus 1 by y, q equal to 2y square. That's why you have to simplify your integrating factor, that is if. Clear? So to solve if, what is formula? E to the power of integration of minus 1 by y with respect to dy. If I integrate this, it will be minus log y. So if you simplify that, if will be going to be equal to 1 by y. If will be 1 by y. If you integrate this, minus log y can be written as log y to the power of minus 1. So log y to the power of minus 1 will be e to the power of log of y to the power of minus 1. F inverse of x will be y to the power of minus 1. So y to the power of minus 1 is nothing but 1 by y. So if is 1 by y. So now we have to solve the equation x by y equal to integration of what is q? Q is 2y square into 1 by y dx plus c. If you simplify this, x by y equal to integration of 2y with respect to dy, not dx, it is dy with respect to dy plus c. Okay. So now x equal to, if you integrate this, y square by 2 cancelled, x into y cube plus cy will be your answer. Clear? So see in your options, x equal to y cube. Y cube term is present in option B. Option B is y cube minus x. Y cube minus x means they have taken minus x on that side. It will be y cube minus x. C is constant, no problem. It can be written anywhere. So C y. So y cube minus x. A is nothing but our C. Clear? So A y. So option B is correct answer. If you get any confusions here, y cube, you take x on this side, it will be y cube minus x. Cy, you take on this side, it will be minus cy. No problem, it will be minus cy. Again, this is a constant term. Okay, for that reason we can write it as constant as a. Minus c I will write it in the form of a. So it will be y cube minus x equal to a y. This is your solution. Don't get confusion here. C, if you take on the side, it will be minus cy. Minus c is again a constant. I will write it as a. No problem. So a y. A is equal to minus c. So y cube minus x equal to a y is your solution. Okay. Because in the differential equations, you have to solve according to these four options. So that's why we have to do a slight change in the last solution with correct form. Okay, if you want to do a slight change means you have to see in 4 options. In that you have to do a slight change according to the solution I am explaining here. Okay, so for that reason option B is the correct answer. Clear? Okay students, now let us move for equation reducible to linear differential equation. Clear? That is, there will be a linear differential equation which will be not form of linear differential equation. That means they will give you one differential equation which will be not in linear differential equation form. That has to be converted to linear differential equation form and you have to simplify. For example, see here, if the differential equation is dy by dx plus py equal to q y to the power of n. Are you getting my point? So now this is not in the form of linear differential equation. Clear? We have to convert it to linear differential equation. Why it is not in the form of linear differential equation? Because y to the power of n is present. Because of y to the power of n is present, that's why that too with the q it is present. Are you getting my point? Y to the power of n is present in the RHS with the q, where q is the function in variable x, p is the function in variable x, p and q may be the constants also. Please keep in mind, p and q may be the constants also. Y to the power of n is a function where n can be any constant other than 0 and it can be unity also. Are you getting my point? This is the differential equation which has to be converted to linear differential equation form. For that, you see y to the power of n where n can be any constant other than 0 and n can be also unity. Are you getting my point? Okay. So now this has to be converted to linear differential equation form. Let us see how it will be reduced to linear differential equation form. I will take yn on this side. It will be 1 by yn dy by dx plus py divided by yn equal to q. Clear? Because this q has to be made free from the variable y. Then we can solve it. Clear? So for that's why I will take yn on this side. Now it is free from y. 1 by y to the power of n dy by dx plus py to the power of minus n plus 1 equal to q. Okay. Now it is in the form of 1 by yn dy by dx plus py to the power of minus n plus 1 equal to q. So here what I will do, I will put y to the power of minus n plus 1 equal to v. I will put this term as v. So what you are going to have now? Minus n plus 1 y to the power of minus n plus 1 minus n means it will be minus n into dy by dx equal to dv by dx you are going to have. See, if I differentiate this, minus n plus 1 multiplied with y to the power of minus n plus 1 minus 1. Plus 1 minus 1 will be cancelled. Minus n plus 1 y to the power of minus n dy by dx equal to dv by dx. Okay. So, what will be dy by dx into y to the power of minus n? It can be written as 1 by y to the power of n dy by dx equal to, this can be taken on this side, 1 by minus n plus 1 into dv by dx. So it will be in this form. Are you getting my point? So now 1 by yn dy by dx can be written as 1 by minus n plus 1 dv by dx. So that is 1 by minus n plus 1 dv by dx plus p into v equal to q. Clear? So further if I simplify this, it will be dv by dx plus p into v 1 minus n q into 1 minus n. So now here you can observe that it is in the form of linear differential equation. Clear? So see, we have reduced this particular equation. We have reduced this particular equation to linear differential equation. Here now p into v of this term, that means if you have to find with e to the power of integration of p into 1 minus n with respect to dx. Clear? So that means this term will be q for you. Sorry, if q is already present, you can take r. That means r will be equal to p into 1 minus n and s will be equal to 1 minus n into q. Okay, so now using these two terms, already I have started with the if. Further, by getting the if, you know how to simplify. Clear? So please make sure that whenever equation is in this form, you have to reduce it to linear differential equation form. That means q is with y to the power of n. Please make sure that q is with y to the power of n. If you find this type of differential equation, you can reduce them to linear differential equation by taking yn on this side. See, it will be 1 by yn dy by dx plus p y divided by yn equal to q. If I simplify this, p into y to the power of minus n plus 1 equal to q. I will follow substitution method now. I will substitute y to the power of minus n plus 1 as v. If I differentiate it, you are going to have like this. So dy by dx equal to 1 by minus n plus 1 dv by dx. Further, I will replace here the terms. Then I will simplify. Okay. So further you will get r value and q value. Using r value you can find if. Using q value you can simplify the equation after getting integrating factor. So you can get your function of the given differential equation. Clear, students? So this is how you have to reduce the linear differential equation to linear differential equation. Are you getting my point? This is how you can reduce the given differential equation to linear differential equation form. Okay. Okay, students. So now let us try to solve this particular problem where the solution of the differential equation you have to find for cos x into dy equal to y into sin x minus y dx, where this is the range of sin x and cos x. So we are not worrying more about this, but we are worrying about finding the solution of the given differential equation. So this is the differential equation where you have to find the solution for that given differential equation. So first let us write it in the form of dy by dx. So if I write it in the dy by dx form, dy by dx will be equal to what? Y into sin x minus y divided by cos x. Clear? So it will be in the form of dy by dx equal to y into sin x minus y divided by cos x. So this is the differential equation which you have to simplify. Next, see here, if I multiply this with y, what you will get? You will get dy by dx equal to y tan x minus y square sec x you are going to get. Clear? Dy by dx equal to y sin by cos is tan, y minus y is y square divided by cos is sec x. So minus y square sec x you are going to get. So this can be written in the form of dy by dx minus y tan x equal to minus y square sec x. Clear? So this will be in the form of indirect. Please see that it is in the indirect form of linear differential equation. Why? Because in the q you have minus y square. As we seen previously that if q is present with y term, we have to make it free with that y. Clear? So make this q free of this y. Clear? That means this y has to be taken on LHS. If I take it on LHS, what is your equation going to be? Minus 1 by y square dy by dx minus tan x, okay, minus, it will be minus tan x divided by y, because y and y will cancel, remaining with 1y. This will be equal to sec x. Okay. So now minus 1 by y square dy by dx minus 1 by y into tan x equal to sec x. Okay. Here, as you have substituted in the previous thing already, which I have explained, here also you have to substitute the term, that is plus 1 by y equal to v. If I put plus 1 by y equal to v, you will get minus 1 by y square dy by dx equal to dv by dx. I think now you got the idea to simplify this. In the place of minus 1 by y square dy by dx, you have to apply dv by dx plus 1 by y will be t, this will be tan x, this will be sec x. So that means your equation will be dv by dx plus 1 by y is v into tan x. This will be equal to what? Sec x. So now this is in the clear form of linear differential equation where you can simplify, because p value is tan x, q value is sec x. P value is tan x and q value is sec x. So from this you can clearly simplify that. From this you can clearly simplify the given differential equation. Okay, see here. Here IF will be what? IF will be e to the power of integration of tan x. That will be equal to sec x. So IF term is sec x. By getting IF term, it will be in the form of v into sec x equal to integration of already q you have sec x. Sec x into sec x will be sec square x dx. You have to integrate this. That means v sec x, integration of sec x square x is tan x plus c. What is v? V is 1 by y. So that is sec x. If I multiply y on that side, y into tan x plus y into c you are going to have. So that is what your solution. So you can check in your answer what is your solution. Sec x equal to, see there, tan x plus c, where y is common. Where y is common, that means sec x, y is common, tan x plus c. So this is your solution. Clear? So where you can take y common as they have written in the answer. So therefore option A is your solution. Clear, students? Very interesting problem. I think you also understood the problem. If you not understood, I will explain once again. By looking at this, first you have to convert to dy by dx. After converting to dy by dx, you have to check, is it in the direct form of linear differential equation? But it is not in the direct form of linear differential equation. We have to convert it to linear differential equation form. For that, I multiply y inside the brackets. So you will get this differential equation where you can take y this side, that will be minus y tan x equal to minus y square sec x. Now minus y sec x minus y square I will take on this side. So it will be minus 1 by y square dy by dx. Here it is minus. If I take minus y square on this side, it will be 1 by y plus 1 by y tan x equal to sec x. So now this plus 1 by y, I will put it as v. I will put it as v. Already we have discussed previously about it. So I will put 1 by y equal to v. If I
put 1 by y equal to v, dv by dx will be equal to what? Minus 1 by y square. So minus 1 by y square dy by dx equal to dv by dx. So by getting dv by dx as minus 1 by y square dy by dx, I will replace this term as dv by dx and I will replace 1 by y as v, and I start to solve my linear differential equation. Here where p is equal to tan x, q is equal to sec x. By using that tan x, I will calculate if term. So if term will be sec x. I will use my solution equation, that is v into sec x equal to q into your if. Q into if will be again secant square x dx. So therefore integration of secant square x is tan x. Replace v as 1 by y and you simplify, you will get sec x equal to y tan x plus c. Therefore option A is the correct answer. I think now it is more clear. Students, we have studied the differential equations in detailed form with the examples and various methods of solving the differential equations and all. So now let us look at the applications of differential equation. That is also very important part for your competitive exams. So for that reason, let us see at, or let us study in detail where the applications of these differential equations are going to be used. Clear? Mainly in the chemistry part, engineering, geometrical part, they are going to use this differential equations. Most of the things in physics, they are also going to use this differential equations. No problem. For rate of change things, to calculate velocity, acceleration, applications of those things, they are going to use the differential equation part, which is of mathematics. So let us study the some of applications of differential equations. Clear? Okay. So what is the problem here? Listen carefully. The equation of the curve which passes through the point 1, 1. That means the curve is passing through the point 1, 1 and where slope is given by 2y by x. Okay. The slope of the curve is given by 2y by x. That means you know that the slope of the curve means it is dy by dx. Slope of the curve means dy by dx. So here slope of the curve is 2y by x. That means dy by dx equal to 2y by x. They are asking the equation of the curve. That means this is the curve which is given by equal to dy by dx. They are asking the curve. This is in the form of differential equation. That means they are asking the solution of this differential equation. Are you getting my point? Listen carefully again. The equation of the curve which passes through the point 1, 1 and whose slope is given by 2y by x. That means slope of the curve is written as dy by dx. So dy by dx will be equal to 2y by x. That means dy by dx equal to 2y by x. Now you have to solve this differential equation and you have to find the solution of that differential equation. Clear? Okay. It is easily solved by variable separable method. That is dy divided by y equal to dx. 2 is remain there only. Okay. 2 dx divided by x. Clear? I will remain 2 here only. I will take y on this side. I will remain here with 2. No problem. So y if I take on this side, dy by y equal to 2 into dx by x. Easily it is in the form of variable separable form. Integrate on both sides. It will be equal to log y, that is equal to 2 log x plus constant term. I will write it as log c because it will be useful for simplifications. So now it can be written as y equal to x square into c. 2 log x can be written as log x square. So log x plus log y. Log x plus log y means log of x into y. So that rule I am going to use here. So it will be x square into c equal to y. So this is the curve passing through what? 1, 1. So if I write, it will be equal to 1. So c is equal to 1. Then your answer is y equal to x square. So your solution is y equal to x square. So what is your answer? Answer is option A, where the solution will be in the form of y equal to x square. I think you got the problem clear. It is very easy problem, that if you understand, it is very easy problem, clear. So for that reason dy by dx will be equal to 2y by x. Why? Because you must know slope of the curve is given by dy by dx. You must know slope of the curve is given by dy by dx. If you know that dy by dx will be equal to 2y by x, separate the variables, integrate on both sides, you are going to have log y equal to 2 log x plus log c. Apply the logarithmic rules, you are going to get y equal to x square into c. X and y are 1, so therefore c is equal to 1, hence answer will be y equal to x square. That is your option A. Are you clear, students? So this is how we are going to use the applications. Let us see some more problems on this. Okay students, now let us go for the second problem on application of differential equations. Clear? So in this problem, what they are asking, the equation of the curve that passes through the point 1, 2. Again they are asking the equation of the curve that passes through 1, 2 and satisfies the differential equation dy by dx equal to minus 2xy divided by x square plus 1. Clear? Okay. The differential equation is given and the curve of this differential equation they are asking where that curve is passing through 1, 2. Okay. So let us solve this differential equation. You can easily separate the variables here. So that's why dy by y equal to minus 2x divided by x square plus 1 into dx. Clear? So make integration on both sides. So it will be log y minus equal to minus log of x square plus 1 plus log c. Clear? Because integrating on both sides, see this function is in the form of integration of f dash of x divided by f of x with respect to dx, because by differentiating x square plus 1 you get 2x. So that's why it is in the form of f dash of x divided by f of x. So it will be log of x square plus 1, because the formula for this is log of f of x. Clear? So I will write it as log of x square plus 1, write minus sign as it is, plus log c. Clear? Okay. So now by using the log properties, you can write it as y equal to, this will be minus log x square plus 1 whole to the power of minus 1. That means x square plus 1 whole to the power of minus 1 multiplied with c. I am writing by using the log properties. Clear? Okay. So by using the log properties, y will be equal to x square plus 1 whole to the power of minus 1 multiplied with c. So it can be written as 1 by x square plus 1. So that 1 by x square plus 1, if you simplify, it will be x square plus 1 into y equal to c. So already they have given the point 1, 2. So your curve is passing through 1, 2. So if you put 1, 2 in this, what you are going to get? 1 square plus 1. That means 1 plus 1, 2. 2 multiplied with 2, 4. So c will be equal to 4. Clear? So now you can see your solutions that c can be written as 4. So that's why x square plus 1 into y equal to 4 will be the answer. Clear? So now let us see the options. That is clearly y into x square plus 1 equal to y equal to 4 is your answer. Okay. So this is your answer. Plus 4. If this comes on this side, it will be minus 4. That's why it is not your answer. Here they have given minus 1. So this is also not your answer. So none of this. Obviously it is not your answer because option A is your answer. Correct answer is option A. Clear? So very simple question, but you must know the conceptual clarity. That means you must know the conceptual in depth. If you know the conceptual clarity, if you have the conceptual clarity, then only you can solve this type of problems of application of differential equations. Clear? So now let us go for another problem of this type. Okay students, so let us see this third question of application of differential equations. Clear? So here what they are asking, the solution of differential equation x into dy minus y into dx equal to 0 represents. So what it represents, that means they have given the differential equation and they are asking what that differential equation represents. There are four options. First one is rectangular hyperbola. That means the solution of this differential equation will be rectangular hyperbola. The second option is straight line passing through the origin. The third option is parabola whose vertex is at origin. Fourth option is circle whose center is at origin. That means in these four, which one is the solution of this particular differential equation? So my dear students, please remember here, by solving the differential equation, you must have a geometrical idea also to solve this. That means you must know the equation of rectangular hyperbola, you must know the equation of straight lines passing through the origin, you must know the parabola whose vertex is at origin, you must know the equation of circle whose center is at origin. Are you clear? So if you know all these geometrical ideas, then you can simplify. You will simplify, no problem of that. After simplifying, if you have the idea of geometry, then only you can answer this question. Clear? So let us try to simplify this. Okay, here x dy equal to, if I take it on that side, it will be y dx. I can write like this. So now you can separate the variables. If I separate the variables, dy by y equal to dx by x. Clear? So now you have separated the variables. After the separating variables, you have to integrate on both sides. So now let us see what will happen after integrating on both sides. If I integrate on both sides, it will be log y equal to log x. So I will write the constant term is also as log c. So now you can apply the log properties and you can write it as log y equal to log of x into c. Clear? So by using this log properties, log y will be equal to log of x into c. You cancel log and log. It implies y equal to x into c. So now you must know y equal to x into c is the geometrical meaning of what? Clear? So as you all know, equation of straight line passing through the origin is written as y equal to mx. Here m is slope, that is constant. So if you see these two, they look same to each other. That means on the place of m, here you have c, no problem. Clear? So this will be the equation of line passing through the origin. So this will be the equation of line passing through the origin. Hence answer will be what? Answer is option B, that is straight line passing through the origin. So take a homework, that is what is the equation of rectangular hyperbola, what is the equation of parabola whose vertex is at origin, what is the equation of circle whose center is at origin, and you try to find the equations, the geometrical equations of other three options. Clear? So if you know the other three options equation, it will be very useful in further studies. So that's why you take that as a homework. If I want to tell you one of the example of parabola whose vertex passing through the origin, that will be y equal to ax or y equal to x square. You can write it as y equal to x square. Clear? So that will be the parabola of lines passing through the origin. Like that you can write the equation of circle is also and rectangular hyperbola also. So you try to find that what will be the equation of rectangular hyperbola, the parabola whose vertex is at origin, and circle whose center is at origin, and try to find out the equations. Clear? So here answer is y equal to xc, where we know the straight line passing through the origin y equal to mx. So m is slope, here c is slope, therefore this equation is line passing through the origin.